Good morning to all of you. Today we are going to discuss on engineering geology, that is 18 CV36, and particularly about module 5, seismology and geodesy. I am Dr. Basra Simpi, working as an assistant professor, Department of Geology, Government Engineering College, Hassan. So in this session, we are going to discuss something related to seismology. So seismology is a branch of geology which deals with seismological activities, that is earthquake related activities. So in this particular session, we are going to discuss something related to earthquake, its causes, effects, seismic waves, engineering problems related to earthquakes, earthquake intensity, Richter scale. So what is meant by Richter scale? Seismograph, seismic zones. We are divided on Earth into different zones where we are going to discuss about seismic zones. In particularly, we are talking about India and total world. And seismic effects, tsunami causes and its effects. So first of all, we would like to know what is the definition of the earthquake first. Earthquake is it's a sudden and rapid shaking of ground occurs due to rapid release of the energy. We can say that earthquake occurs occasionally, but the destruction causes lot of life losses and property losses. So generally, we are talking about the focus point, hypocenter, epicenter. So you might have been more aware about the word called epicenter. So people using this focus point or hypocenter very less. So focus or hypocenter is the exactly the point where the inside the earth where really the earthquake originates. That point is what we call it as an epicenter or hypocenter, where really the earthquake originates. Exactly vertical to that, vertically above to the surface of the earth, that point what we know as an epicenter. So whatever we are knowing about the epicenter, we are talking about the epicenter from this area, the epicenter from this particular point, the earthquake has trigger, which is moving in all the directions, and the intensity keeps on reducing as you move away from the epicenter. Okay. So particularly we have divided this earthquake into different types. We can say that based on the depth, particularly we are talking about the depth aspect. Shallow earthquake, intermediate earthquakes, and deep earthquakes. So based on the depth, what we are talking about, if it is less than 70 kilometers below the ground surface, that is what we call it as shallow earthquakes. So when we talking about the numbers of earthquakes, more number of earthquakes are taking place at this particular shallow type of earthquakes. Intermediate earthquakes means it is between 70 kilometers to 300 kilometers beneath the surface of the earth. So these are moderate, we can say that. Deep seated earthquakes, that is below the 300 kilometer to 700 kilometers, 300 to 700 kilometers below the surface of the earth, then we are going to consider that as deep seated earthquakes. When we are talking about the numbers are very less. Earthquake which are deep seated are very less in number when compared to shallow and intermediate type of earthquakes. You see the figure of this. So epicenter exactly above the exactly hypocenter or epicenter focus point is exactly above the epicenter, that is vertical. That length between the epicenter to the focus point, that is what we call it as focal length. So different observation stations will be there available at different junctions, and that particular observation stations we are going to record what is the intensity of the earthquake. Let us move on to the further things. What might be the cause of the earthquakes? What are the different causes of the earthquakes? Will that will be broadly classified based on the different categories. So let us take one by one. Surface, or we can say it as dynamic causes. So this occurs due to the collision of waves along the sea waves or sea shores, working of heavy machineries, and heavy blasting mines. Mining activity is also very important thing to cause earthquake. Flowing of huge rivers, water at deep slopes, railway tracks along with the hill slopes. So these activities which are going to trigger the earthquake of low intensity. So generally we are coming across low intensity earthquakes under these settings. Few of them are strong enough to perceptible, and some of them are very destructive. Some of them are very little bit in effect, and when you are talking, some that are more destructive in nature. So next one is volcanic eruptions. Because of the volcanic eruptions, there is a possibility of earthquake. During the volcanic outburst, Earth trembles. It's still uncertain geological problems. Other related problems are also there, which are related to earthquakes, volcanic eruptions. Leads to vibration of the earth, or earthquake leads to eruption of lava. So these are all the different reasons. Among that, this is also one of the reasons. Folding and faulting activities. Folding and faulting activities. You might already know about what is meant by foldings, faultings, and all those things. So folding and faulting occurs when the earth crust undergoes a stress condition. When you are going to put more stress on the earth crust, so that is going to outburst somewhere or somewhere. So when stress accumulating on one direction, the rock is subjected to fracturing, and fractured blocks may even suffer related to displacement. There is a displacement, as you know, in the when we are talking about folding and faulting. So give rise to fault. When there is a continent, we have different plates of the continental plate and oceanic plate, something like that. So when there is a collision between continental plate or continental plate collision, continent to continent plate collision, sometimes continental plate to oceanic plate collision also happens. So whatever the consequences it is, between any collisions between the different plate, it implies to folding and faulting of huge rock masses into Himalayas and other mountains. There is a collision between one plate to another plate that leads to different type of folding and faulting activities. Okay. So here we are going to see some stress is there on implanted on the surface of the earth, and there is a fracturing zone, faulting has taken place. If you are talking about particularly when you are talking about the folding and faulting, at this particular junction, there is a faulting plane. So what are the effects? It is a complex manner which moves up and down as well, from the sides to sides. It depends what might be the type it is. There is a movement. If there is a movement, there is a movement means there is a destruction. There is some geological problem related to that area. So that may cause some earthquake. Intensity, duration of the earthquake, distance of the place from the epicenter, and nature of the ground mass. So what from where, how much distance it is far away from that particular place where really the earthquake has originated. That makes the big difference. So here the instrumental, when you are talking about the instrumental aspects, we have different intensities of earthquakes. So intensities of earthquake are measured with the scale called Richter scale. Richter scale is one of the generalized instrument measurement for the earthquake. So these are all the different things. If you are going to record, if it is very feeble or less than, so recorded by sensitive instruments. Okay, if it is less than 1 centimeter, acceleration produced centimeter per second. If you are taking it instrumental, if it is less than 1 centimeter, recorded by sensitive instruments. If it is very feeble, it is more than 1 centimeters, noted by few people. People may come to know some vibrations are there in that particular region. Will come to know that. If it is feeble, it is 2.5 centimeter, felt by some of the people at rest. Moderate means 5 centimeter, felt by people in motion. Fairly strong means it is acceleration produced per centimeter. If it is very less. Strong means 25 centimeter. Very strong means 50 centimeter acceleration produced. So something it goes something like that. If it is very disastrous means it is 700 centimeters. Few structures are left standing. So catastrophic, it is very important. That is a total destruction of the whatever the mass what is there. So safety measures in the seismic waves. It is impossible to stop earthquake, and effects depends upon the place to place. All earthquakes can create a great damage of life and building a natural ecosystem. However, it is possible to minimize the impact by predicting through. We can predict the earthquake. So this might be the reason where there is a possibility of earthquake, something like that. We can predict. So seismic waves, how these waves are produced. The focus related to strain energy in several types of wave motion, that is what we call it as seismic, or we can say that earthquake waves. So these waves travel in all direction in different paths, modes at different speeds and propagation densities of the whatever the material what we are having inside the earth. So which will travel. The speed increases with the density and they reach the ground surface and spread out in ever wide spreading circles from the epicenter. We are talking from the epicenter. If it is going to move away from that particular point, that will be keeps on reducing. So what are the different instruments for measurement of the earthquake intensities? We have different countries are following different standards instruments. So generally nowadays accepted one is Richter scale. In the past, different world gram scale of India. So that was the instrument what we are using earlier days. Omorari Omari scale in Japan. So they are using that Ruciferal scale of Italy. So Richter scale of France. So it's a so Richter is the standard scale among the above mentioned scale. In the years 1935, Richter developed the different types of logarithmic scales for comparing the magnitude of the California earthquake. So generally, we can say that the instrument, standard instrument, what we are going to use is Richter scale. Seismograph, sensitive instrument that records the vibration of the earthquake using pen rotating drum, springs, wires. So these are all the technologies that we are going to use. So seismograph is that a minute occasional occurs inside the earth waves are recorded in zigzag patterns. So these are zigzag patterns that are going to utilize in that. Seismograph. So vibrations will be detected by seismograph are commonly recorded on the photographic paper as a series of zigzag lines called seismograph. Seismic records of different kinds of earthquakes. So they are going to produce namely P waves, S waves, and L waves. So P waves, that means your primary or pull and push waves. So these primary waves which are produced over here, depending upon what type of seismographs. So you know the difference between seismograph and seismogram. So different types of waves will be generated. So primary waves, that is athwa push and pull waves. So these are the first recorded in the recording station as compressive types of push and pull waves like sound waves. These waves can penetrate through. So you see the property of this particular P wave when we are talking about are push and pull waves. So they can penetrate through solids, liquids, and gaseous media. They travel at a speed of 5.4 kilometers per second. So different waves have different properties. So when we are talking about primary waves, so these waves have the capacity to or have the capacity to penetrate through solids, liquids, and gaseous media at a speed of 5.4 kilometers per second. So let us see the property of S waves. When we are seeing the property of S waves, these waves are something different from that type of primary waves. So these waves are caused by shake of the earth, such as light waves, which travels at a speed of 3.5 kilometers per second. So here, this can penetrate only through solid media. They cannot penetrate through liquid and gaseous. Secondary waves or shake waves. These waves at a speed of 3.5 kilometers, this can penetrate only through solid media. So next one is L waves. So longitudinal waves are long surface waves. Love waves generally used to word love waves also sometimes. So these are the waves produced by reflection and refraction of P and S waves in the immediate neighbor of the epicenter. So these travel with a rotary motion of the vertical planes like sea waves. They travel at a speed of 1 kilometers per second only along the ocean floors. So if you look at this figure at the bottom side, so body waves, surface waves, first waves, that is your P waves, first P waves. So just like in ECG instrument, all the things, what are the vibrations which are coming in the because of the earthquake will be recorded. So as far as the distribution of the earthquake, Indian continent has been divided into different zones based on the intensity of the earthquake, such as zone of maximum intensity, zone of intermediate intensity, zone of minimum intensity. As far as areas which are covering under this particular zones or intensity zones are concerned, so in the zone of maximum intensity, it covers the northern eastern region of the, especially the folded chains of Himalaya. Graphically, it's going to geographically it covers the important states of Jammu, Kashmir, Assam, Himachal Pradesh, Nagaland, Uttar Pradesh, etc. So these are the areas which are coming under the maximum intensity zones. So as far as the intermediate intensity zones are concerned, it covers the important regions of Indo-Gigantic basins covering areas of Punjab, West Bengal, Bihar, etc. So as far as the zone of minimum intensity, so here we are going to have Karnataka, Tamil Nadu, Kerala. So all these things are coming under this particular zone. So as far as the distribution, here world distribution, if we are going to talk about, so this is about the exactly the pictorial representation how these areas are being distributed. Zone first one, zone first, zone second, zone third, zone fourth. So they are categories. So here we have made four categories out of that. So under which areas are coming under the different zones that has been covered in this particular PPT. Here next one is as far as Indian distribution, Kutch, Gujarat in 1819. So Assam in 1879, Bihar in 1934, Anjar, Gujarat, Peninsular India, South India. So these are all the different earthquakes which are triggered. So worldwide distribution, if you are talking about, first one is the circumpacific seismic belt. Second one is Midland Atlantic seismic belt. Third one is Alpine Himalayan trans seismic belts. So these are all the, as far as world distributions are concerned. Okay. So important criteria of to build earthquake resistant structures. So for civil engineers, so the points are very important. Light and elastic construction. So light and elastic constructions are very important, needful as far as civil engineers are concerned. So earthquake, we cannot control earthquake, tsunami, all these things, natural disaster we cannot control. But even in these different zone, if you are going to construct some of the earthquake structures, earthquake resistant structure, you have to think. So here, what are the properties of that? So you have to think of light and elastic construction. Heavy light construction with uniform depth of foundation is important. One of the, so one should strictly utilize the best quality of the material according to the standard specification, what already known about that. The size of the doors and windows should be minimized. The height of the building should be kept in a single floor only. Seismic waves should be recorded using the seismograph before selecting their site for the construction. So when you are thinking of a mega structures, so you have to understand the seismology of that area. Okay. If you are going to think of a construction of some dams, you must know the history of the seismic structure, seismology of that area. So what are the different earthquakes which are triggered in the past should be known, well known. Okay. So further, making of reinforced structures, column should be maintained to distribute the load of each column. Use of polymer and lightweight materials, that is also very important. Avoid stone clouding and stone pillars. You have to think of that. So bridge with screw pillar and foundation stand better to the shocks of the earthquake. The walls should be continuous in nature. The long walls and cross walls to be created simultaneously without any joints. Strongly designed steel frame or reinforced ferro-concrete structures possesses high degree of resistance, should be well maintained. So these are all the some of the things that we have to take care as far as your structures are concerned when you are thinking of a being a civil engineer. What are the precautionary measures that you have to take care when you are constructing in different zones of the earthquake regions, earthquake prone zones or less zones, something like that. Okay, let us move on to the next one, that is tsunami. But I've been heard about this word called tsunami. It's a Japanese word meaning Tall tidal waves are generally harbor waves. Nowadays, we are quite familiar with the word called tsunami. The intensity of the tsunami is measured by the speed of the height of the water waves on land. The runoff of the water on land is related to the magnitude of the earthquake and may exceed 30 meters. That means about 1,000 feet for largest tsunami. Occurred many a times in the history. Huge mass of rise in the water rushed at the tremendous speed, destroying and devastating whatever comes on its way. Tsunami caused a widespread damage, total destruction of the life, property of the coastal areas. Indonesia, Malaysia, Thailand. So these are all the prone zones for tsunami. Okay. The first time tsunami in India struck in 1874 near Gola, a small town in West Bengal, killing 12 lakh people. To see the intensity and the people of death in case of Gola area. Second tsunami hit in Andaman and Nicobar Islands in India in 26th June 1941, a record of magnitude of 8.5 intensity in Richter scale. The latest tsunami occurred in 26th December 2004. You might have been more aware about this Indian Ocean with magnitude of 8.9 in Richter scale, killing thousands of people, lakhs of people in Chennai. So people are more aware about this tsunami word in 2004, December 26th, because of the Chennai tsunami. People are more aware about this tsunami. So what is the ocean condition? How the ocean condition? So different portions of the oceans. So the top one is continental shelf. After that, we are having continental slope, continental rise portion, basal plain, at different depth on the left hand side. What you are seeing is 200-meter continental shelf. From 200-meter to 2000 to 3000 meters, it is continental slope. After 3000 meters to approximately about 4000 meters, it is what we call it as continental rise portion. Abyssal plain means it is around the 4000 to 600 meters below. So the deepest portion of the ocean, that is what we call it as the oceanic trench. Okay, submergence ridge, what you are seeing on the right hand side, volcanic islands, what you are seeing on the topmost portion of this. Okay, so the oceanic trench with a depth of 10,000 meters. These are the different, the deepest portion of the oceans. So we must have a draft figure of how the ocean basin looks to be, something like that. Tsunamis are caused by a sudden movement of the earth that happens under the sea. So what is the difference between the earthquake and the tsunamis? If the earthquake triggers inside the ocean, that is going to create some waves. That is what we call it as a tsunami. After the most destructive tsunami caused by the earthquake, but causes it can also include volcanic eruptions. Because of the volcanic eruptions, also there is a possibility of tsunami. Landslides also one of the reasons. Hitting the comets, that is also one of the reasons for the tsunami activity. Landslides cause the tsunami when debris fall into water. So this has the same effect of dropping a bigger stone into a pool. So that is going to create some ripple waves. So that is also one of the reasons this travels until it is going to comes the land portion. Okay, that is what we call it as tsunami. Volcanic eruptions also causes tsunamis. Because of the volcanic eruptions, volcanic activity inside the ocean, so there may be a bigger reason, so the great cause of the volcanic eruptions. So, what are the different effects of this? You might have been more aware of different effects of the tsunamis. Loss of life, properties, towns, villages have times to escape. So, since 1850, a tsunami that is responsible for loss of 4 lakh 30,000 lives. It has a tsunami hits, land leaves. It's going to, we cannot escape from the tsunami. Some of the times it is going to fire accidents. Because of the tsunami, there is a lot of fire accident, electrical disconnections. From the electrical problems, also many people are dying out of this tsunami effect. Diseases. After the tsunami, we are going to, that area will be totally contaminated because of the flooding of the water. So there may be a scarcity of drinking water and a number of diseases will come. because of the flooding activity which is in that area, heated area, at nearby areas also. So that is going to create a lot of deaths because of the diseases which are causing because of the tsunami effects. So as far as environmental impact, so it roots up trees, plants, and destroys animals, habitat, and total ecosystem nearby get disturbed. Land masses, so animals nearby, that also creates a lot of problems. And solid waste, disaster debris are most critical environmental problems after hitting the tsunami. So as far as cost, massive cost hit the, so there is a lot of financial losses, infrastructural losses, psychological effects. Victims of the tsunami events after the suffer psychological problems because of the death caused by the tsunami. So that is what we call it as post-traumatic stress disorder. So okay, so that is also creating a lot of problems which are related to tsunami. So in this particular session, we have learned something related to earthquake, that is tsunami. What are the causes? What are the reasons of earthquake? Whether it is a natural reasons or anthropogenic reasons? What are the responsible for earthquake and tsunamis? So what we have learned in this today's session about these points, what we have covered, earthquake regions in India and world, we have known. So what you are going to do after knowing all these things, so further knowing about all these things, so this knowledge should be applicable in the field of civil engineering field in order to have that safety, stability, economy of construction, at what site you have to take the materials. So these are all the course outcome what we have expected from this particular session, what we have learned. So some of the multiple choice questions, you have to answer these multiple choice questions. So the region of initiation of this seismic energy is called the epicenter, hypocenter, area of great building damage. This area of least building damage. So that is the question number one. You have to answer that. Earthquakes are produced during plastic failure within the mantle. Option B. Brittle failure during the faulting. Option 3. Mushrooming during the faulting. Option 4. None of the above, we can say that. Seismograph is a device used to, you know what is meant by seismograph, seismogram, Richter scale, all those things. So different options are there. Sound an alarm, prevents earthquake for occurring, record the vibrations produced during an earthquake, calm the seismologist during the earthquake. So these are all different options what they have given. In the fourth question, on the globe scale, an average of 9 lakh earthquakes, 90 lakhs. So these number of earthquakes the year with a magnitude of below 6, 7, 2.5, 5, 4. So which of the following is not categorized under the geological hazard? Topographical, topo, tropical cyclone, earthquakes, volcanoes, floods. So these are all the options. We have to identify which is the correct answer in that. So question number 6, which one of, so which one is the second largest magnitude earthquake occurred during last 100 years? So option 1, 2001 Bhuj, 2004 Sumatra, 2015 Nepal, 2005 Kashmir earthquake. So to identify which is the correct answer for that. Seventh question, in which tectonic environment you can find the surface expression in a form of folding? Extensional, compressional, strike slip, all of these. So next question, in which type of the faults the hanging wall is moving up with respect to footwall? Okay, in the previous modules, you know about what is meant by normal fault, slip fault, reverse fault. Okay, based on that, you have to tell the answer. So thank you for the today's session, session number one, and we will continue in the next session. Thank you.